Hello and welcome to the next episode of the Klingberg Wing Mark II development. As always, I'm Raul Klingberg, your host. So today I'm sitting in the refurbished and upgraded pilot's cage cockpit of the wing. I just finished up all the work on it and wanted to share some of the changes that I made with you. And you get to see some of the new cool stuff that we're doing. Physically it looks pretty much the same, but there is one major change. You see it sitting here in front of my face, and that's the I got the permanent installation set up for the AHARS system, attitude, heading, and reference. It consists of a Pixhawk and some other instrumentation, and then the display is a 7-inch tablet. I think I've introduced it in a previous video, and I thought I'd show you how I've integrated it with the cockpit. Then I'll show you some of the other changes and features that I've added to the design. So you hang in there. I'm going to spin you around and come back and show you some of the details. Hi, I thought I'd take a quick break in the middle of the video here to tell you that the reason I made this video is so that people who are currently introductory or free members of the Patreon site have a chance to see the types of videos that they'll have access to when they become regular paying subscribers to the site, to the channel. Most of the technical information that I disperse is for paying members only. And for YouTube, I have memberships available there, and that's how you get access to these types of videos. Occasionally I'll put up something that's not that critical or not that interesting technically, just for the general public. But if you really want to follow the project and help support it, then you become a subscriber or a paying member. We're getting ready for a series of very interesting test flights. We're going to start working towards higher altitude, and we're going to go out and start doing that testing in a couple of weeks. And the only access that will be available for videos and discussions of the flight tests and showing all of the flight test data, everything, all the technical information will be available to paying subscribers only. So now's the time to get on board. If you want to get that really cool flight video, that's how you're going to get access to it. And if you want to help support the project and keep me working on it, sign up now. It's not expensive, you know, a few dollars a month. It's not a big deal to you, but to me, it's what makes the program go. Every single dollar that comes in goes right into the program. None of it goes in my pocket. So I encourage you to sign up and help support the project, especially if you want to see the way cool flight video. So now back to our regular video. Here you can see a kind of quartering view of the display. As you can see, I'm running Mission Planner, free software online, and it's both good, bad, and ugly. The good thing is it's highly configurable. You can make it look like whatever you want, do pretty much whatever you want. On the downside, it's completely reconfigurable. You can make quite a mess of it when you're trying to set it up, and it is an arduous job. You know, pluses and minuses. Anyway, so there it is. It's mounted on a tablet mount, and that tablet mount has a ball and socket joint and a clamp to go on the tube, so I can angle it, move it up and down, do whatever I want with it. It is just sturdy enough to keep it from moving in flight. It's just sturdy enough to tap the screen and make changes without changing its mounting position. So I'd like to have a better mount, but for now, this is what I got. There's a short extension coming from the tablet, goes over to the line over here, so I can just unplug that and take the unit off the cage and pack it up for travel. The long extension line actually goes all the way down this tube here, turns the corner, heads up front. You can't see it because it's under white duct tape. Comes up, goes around the curved front end, and goes to the actual equipment box that generates the data for the display. This also disconnects right here so that I can easily take the box off. This box is secured to the fabric here with Velcro, so I can just peel it off and pack it up for travel. This has the GPS on-off switch. It's got the PixHawk inside, and it has airspeed data. It has an annunciator to let me know when it's turned on. We see the blue flashing lights, so we know that it's acquired GPS satellites. And what else I got inside? Charging cables, so forth and so on. So we had problems with this before. It was mounted over here on a solid surface. As we went across the dry lake bed, it's pretty rough, and it was, because this is right over the nose wheel, it's just going bam, 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 bam. And the frequency of that vibration was too high for the unit, and it just clipped off, and we got no data. So I've mounted it on this piece of fabric here, and I'm hoping that this will absorb enough shock so that the unit will keep collecting data. Here we see some silicone hoses coming out, and they're going up to the pitot tube. The pitot tube used to be mounted on the box, but the box, and it was okay because the box was exposed to the free stream flow coming in, but given where the box is now, it wouldn't be. So I've taken it off the box, and it has its own mount, and it clips on to the front compression strut. This is both the static and the dynamic portions of the pitot tube system. And you'll see that I have a little piece of plywood here, and I have this white clip attached to it. Here's a sample of it right here. And I found these on Amazon, quite handy. They're 1-inch like PVC pipe hangers, and they just happen to clip on to 1-inch tubing perfectly. And so I can just simply push on that plastic mount, and it'll pop off of this tube, and I can then set it with the box and pack it up and travel that way. So it's pretty easy to disconnect everything here for transit. And the cable, the big extension cable, that just stays taped on to the pilot's cage, and that's fine. You might have noticed as I went by here that there's an orange line hanging down here. This comes down to this new control horn bracket that's on the rudder pedals, and this is the exciting new yaw control system. We had debates in the past about whether I want active yaw control or not. Most previous similar designs have gone down that path and said, oh, got to have the yaw control. From my last flight, I thought, you know, I'd rather have the yaw control. I'm so accustomed to flying full-size aircraft with yaw control. I fly a lot of my models without any yaw control, but full-size is always different. And that flight showed me that I'd rather get rid of the adverse yaw by making the winglets active, which I'm in the process of doing. This orange cable, actually it's a piece of heavy-duty fishing line. It's like 200-pound test. Same stuff we use for the weak links. We'll clip into one of these holes here on the rudder pedal, and you can see as they go like this. As I push on a rudder pedal, it goes down, and that will pull the winglet open. And then if I go back the other way, this line goes slack, and there's a spring on the winglet that will take up that slack. Currently, I can only apply left and right yaw control. I cannot depress both pedals for speed brake control because they're rigidly attached to the nose gear down here via these push rods. I'm sure I'm going to modify the system and make new rudder pedals where I can do both. That I can either choose to use left or right, or I can push on both to give me dive brake control. It's always nice to have on a glider. Now up here I had to add a couple of turn points. This is just piano wire that is hooked into a plywood plate that's epoxied to the bottom of the wing, and that is a turning point. That's a turning point. It's a 90-degree turn for the line. Being a piece of steel wire, it's quite slippery. Don't really need a pulley or anything. It'll just slide right over that. So pretty simple. Let's see what else we got. I have the new brackets for setting up the tow line. A weak link between here and the tow rope. And there's a series of holes here that we can set it vertically depending on, we want to try to tow directly through the CG. Right here is pretty close to it, but there's some alternates here that we can use. And I'm using the double knife line cutter. This normally is here, and this is normally here, and it would have the weak link going through it. And when you pull on the the release cable, like that, goes up on it, and the two knives cut the weak link, and off you go. And I've added a guide tube for the tow line. Let me see if I can go to the other side, show you that. It's just a little piece of aluminum tubing glued to the bottom of the wing. And inside that I have some flexible rubber tubing, plastic tubing, that the line runs in. And rather than try to make a fancy bend on the aluminum tube, I just kind of followed the bend of the wing, left the plastic tubing hanging out here for going around the corner. And if anything goes wrong with that, I can always pull the plastic tubing out and replace it. Now, in the rebuild process, or upgrading process, I had to take the pilot's cage off the wing to do the higher load testing work. And in the process of removing it, I discovered some pretty ugly bolts. Let me see if I can put one up here. There it is in my hand, really rusted. That bolt was one of these there, the pilot's cage. In fact, there were 8 bolts that were rusty like that. So there's 4 on the side, 4 and aft, and up above, 4 and aft, and they all had corrosion. Some of it looked like galvanic. Turned out it wasn't, it's just ordinary corrosion. But none of the other bolts on the pilot's cage had that, none. Whether it was graphite steel interface or aluminum with steel pins, you know, none of them were rusted. Maybe a little light rust, but nothing critical. First I couldn't quite figure it out. It's like, why those 4? And then I remembered that these tubes, the vertical struts, have a wood plug inside of them here, and that plug prevents crushing the tube and helps take the bearing loads from the bolt. And when we had it at the beach, many times at the beach, it's very humid there, and I suspect that that wood soaked up humidity out of the air. It's never been underwater or wet, so probably just sucked up the humidity. Means I probably should have varnished that wood thoroughly. And so those bolts, this rusty bolt was because it was sitting inside a wood plug that was wet, and it rusted the bolt. Now, I could go back and redo it all, but I believe that those wood plugs are glued in now, so just not a very friendly thing for taking it apart. So what I did is I switched over to stainless steel hardware, pretty much everywhere. Anywhere on the pilot's cage that's bolted or pinned is now in stainless steel. So that'll prevent any more unwanted corrosion. Oh, let's see. And over here you get another little look of the cockpit, and the one window is covering up the instruments right now, the artificial horizon, the head-up display, but that can be moved over and you can put it over the GPS map or whatever you want to do with it. And I'm going to take you inside the cockpit now so you can see what it looks like from my point of view. I'll spin you around. Here we go. Okay, you can now see my view of the glass panel display for my AHARS system. And you can arrange this screen just about any way that you want. What I have set up here is I have the gauges enlarged so they're easy to read, and all I have to do is glance to the side and I can quickly see, you know, my rate of climb, my altitude, my airspeed, and my heading.